Okay, so let's start with the outlier percentile in the statistic part. So here we have so many statistic functions, right? But very few are available for finding the outliers, right? So let me first define what is the outlier there and what kind of operations we can do or we can perform there, right? But before that, let me import my pandas basic library as pd, and we are going to import different data set. This is data set is called from read csv. I'm going to import height heights dot csv, right? So this data set is already inside my like you can see inside my Jupyter notebook or the Anaconda platform. So this is easily accessible there, right? If it is not there, you will have to upload there, then only you can run this code. Otherwise, this will show an error. Once we have acquired this dataset here, so I'm going to display on the screen what are these. So where here we have name and height. All right. So our objective is to detect our outlier using percentile, right? But what is the percentile here? Let's consider this percentile over here. Suppose we have random data set in our screen, like suppose we have 7, then we have 9, then we have 12, then we have let's say 3, right? Then let's say we have 4, then we have 1, then we have let's say 19, then we have let's say 8. This is the random data set we have in my data frame. So what the number one, what we are going to compile it, first and foremost we are going to sort this data set in the increasing order or decreasing order. So I'm going to sort this. First is the lowest one, then 3, then 4. So we have 1, 3, 4, then we have 7, then we have 8, and then we have 9, and then we have 12, and then we have 19. All right. If you want, you will find the obviously here is some certain data set, certain formula to find out the percentile. If I'll say the percentile, like the percentile of this data set is near about 8.5. What does it mean? Which means the like percentile or like 50 percentile of this data set is 8.5. What does it mean? It is literally means 50% data is below 8.5 and 50% data is above 8.5. Okay, let's consider it's a 7.5. So here we will find 50% data below 7.5 and 50% data will lie above 7.5. This is literally meaning of this 50 percentile. When you'll talk about the 75 percentile data set, which means let's say I'm saying 75 percentile and it's around 9.5. I'm assuming the formula is giving 9.5 value. You will focus on the data set. The value 75% value will lower than this 9.5 value, and beyond this 9.5 value we will have 25% data, right? This is roughly idea, not exact or the precise definition, but in a single statement or a thumb rule you can use your outliers there, right? But we are considering what is the percentile in very first condition, right? Suppose I'm saying 10 percentile. I'm not using percentage word anywhere. You just mark my word. I'm not using percentage. Percentage is different from percentile. Alright? Percentile is the cumulated. means cumulative value, all the gained score, whereas percentage is overall with respect to the highest marks, right? For example, in the examination which is maximum score is 100, if any candidate is scoring 100, which means he is scoring 100 percentage. If the topper is, I'm saying topper is scoring 92 percentage, so the percentile of this class will be 92, will be 100 percentile for this class. This is literally means, right? So this 92% which is gained by the topper candidate will be rank 1, and this rank 1 obtained marks will be 100 percentile. This is the difference between percentage and percent. So percentage is fixed, every time we will have 100 out of 100, 100 percentage. But in any case, like suppose examination is very tough and the candidate is getting only 23 out of 100, but you then don't have any choice except this statement: 100 percentile is representing by this 23 number. This is the literally means of 100 percentile, not percentage. All right. So we are going to illustrate more about this percentage value. Here we have 10 percentage. Let's say I'm having 3.5, which means the value below 3.5 will be only 10%. Above 10, rest 90% value will lie beyond this value. Let's go back to the table itself, or the height CSV dataset. We have head column where we have this dataset, right? So we are going to detect the outliers, right? So let me perform some maximum height formula here. Maximum threshold value, threshold threshold. This would be equal to TF, and then for HEIG height column, I'm going to calculate quantile function within 0.95, right? So you can see it's not showing any error, which means my value is stored in my variable there. So you can see it's showing 9.68. What does it mean? It means 95% data set is lying below 9.68 something, right? This is the threshold value. So the data set above this 95% will be outlier. In my condition, this is my threshold value. This is my this one boundary values, right? Now come back to here. Suppose in any class, there is a height of any, like set of height of my candidates, right? So in this set of height, I am having this set of like 2.21.5, 17.9, and suddenly I got 86.2, and then finally got 12.5, and then got 15.4. So my question is, out of these values, 5 values, which one is called outliers? So we have this out of the boundary, out of the box. So we cannot say this is the wrong data set. Might be height of any candidate, all we can, but this will be outlier for my cup of tea, my domain, right? So I'll call it beyond this in, and I'll try to like this one, beyond this one, right? Why? Why we are going to I mean neglect or reject this value? So let's take this mathematical behind this. We have 21.5 first value, then 17.9 as in second value, then we have 86.2 is the third value, and then we have 12.5, and then we have this 15.4, right? And let me take wrap in the round bracket and divide by number of candidates, like 1, 2, 3, 4, 5. So I'm going to divide by 5, right? So this is the mean of my existing data set with the outliers. When I'm not going to neglect or reject the awkward situation, or awkward means odd value here. The moment I'll dig out this value and will take the average value again, or the mean value again, you can see the value is now 16 value. So 16.825. This is the mean when we are neglecting one outlier value, and this is the mean when we are accepting, right? And you just focus on this, like this 30 is also beyond all the rest value. This is beyond this 21, 27.9, 12.5, or 15.5. What is the effect on this on our graph? So this is the first effect, that we will get the very deviated mean when we are accepting outliers. Even a single value can deviate your entire mean value. This is the first part, right? What's the other part? Other thing is, if you try to create the histogram for the same, when we will create the value 12, then 17, then 12.5, then 21.5, then this one, and then suddenly we have 86.5. So here we have 86.2, right? When you are accepting this 86.5, which means the mean value will be somewhere here at this point, which is 30 point something, right? What's the exact value there? 30.7, right? When we are neglecting this value, the mean, so which is far away, very far away from these actual data points, right? Can you see this data, this mean value is very far from my actual one. When I'm neglecting this mean value, or this 86.2, the mean value is now 16.86, which is somewhere this one. So which is more justified? The mean value should lie in between the most of the data points, or deviating from the. So of course we are accepting this mean value. We are having this deviation, this far away point, because of this just single value 86.2. This is the drastic change in your calculation, and this is going to give wrong output, wrong prediction. So what's the impact when you are going to accept the outliers? You are not detecting outliers, or you are not deselecting the outliers. The first question is mean. You can see the mean value is totally entirely different. Second value is histogram position, or the graph itself is telling wrong story there. Third value, wrong prediction. We have very far from the actual one, right? So we have wrong mean, we have wrong histogram means, right? Right? So wrong means very far away from the actual positions, right? From the ground truth, right? Sometimes I would say false positive, right? So this is the drawback when you are accepting this outliers. Now go back to the code itself. Code saying 95 percentile value for the given head or heights in any class is this one, 9.6. Okay, I'll go. Now let me check how many values are there. Those are above this. I'm going to height, and this height be ig, and I'll take the condition. What's the condition? Condition within the frame satisfy this condition is Imran. So Imran is having height above 14.5, and if you look at other candidates, they are around 5.9, 5. 5.1, 4.9. We are getting very true result that we have selecting the outlets. So Imran is out of the box candidate who is having height, who is very tall in my class, right? So I'll say to the Imran that I'll kindly excuse us. We are not your domain. We are counting something else, right? So what we are going to calculate? We are going to calculate some other candidates who is having very low height also, right? So I'm going to set this that minimum threshold is equal to this df again, and for the height column I'll take the dot quantile, and within the quantile 0.05. So I'm going to take 5% from the, and then as well as value. So below 3.6 I'll get this again. We'll check identify who having this code. Of course this code. Joseph is having this height. Might be is wrongly entered. His height is wrongly entered in this. So this might be human error. But you cannot go with the human error. You cannot go with the daft candidate. You cannot go with the very tall candidate, right? So we are going to remove. Our next objective is to remove outliers, right? So what I'll do, I'll go with the df, this one, right? Within the df, and I'll wrap this condition into the round bracket. So this will be the first condition. And within the second condition, I'm going to wrap it in the df height is greater than maximum threshold, right? So, okay. So I'm going to take the value greater than minimum value and less than maximum value. This would be the acceptable value, right? Previously, we are finding these candidates. Now we are accepting in between these two conditions, right? The maximum, the spelling of this, let me check it again. Okay, so this is the variable where we have 95 percentile, and that's it, we have done. Okay, so do we have any uh, so when I run this code, so you can find this is perfectly fine, where we do not have 95 percentile or very low candidate. So these candidates are having very perfect height set, right? We don't have a very low height data set, either very higher data set, right? So what's our next step? We are going to
Uh,
yes,
Sorry for interrupting. Uh,
are you getting my point? Means number of candidates those are having greater than this value will be means more data set you will find, not
yeah,
only one. So
yeah,
in
but my
this
question was,
uh,
uh,
use very high data set, only 5% upper or 5% नीचे we will lose the data set. Did you get my point?
yeah, I got it, got it.
Right. So this is again, let me revise one more time. So this 50 percentile will be tuned in such a way that 50% data set will lie in between this one and this one. The name itself saying कि 50% data इसके पीछे लाओ, जो भी आप वैल्यू निकाल के दे रहे हो, और 50% डेटा इसके आगे जाना चाहिए, right? So Google, when you Google for this percentile, go for the images, then you can find this one. Can you see this one? This is 85 percentile, right? So 85 percentile value will be 42,000 something, where we will have rest 15% data set. If you'll count this value, this is 15, right? So yes, this is 15, and 1 2 3 4 5 6 7 8 9 10 11 12, right? 12 13 14 15. So out of 12, 3 has been assigned to the 20 85th percentile. Rest 20 to 30 33rd percentile line, this one. अगर आप ये लाइन देखोगे तो इस लाइन के below में all the 20% data will write, right? Oh sorry, 33rd data will write. Below this one, 20% data will lie, right? So this is the automatically tuned by the value. Now what's our, we are going to explore next, we are going to explore Bangalore property site. So I'm going to take another example to have crystal clear idea what's the like statistic mean and how statistic is being used in data science. This is most frequently asked question in the interview कि statistic हम use क्यों करते हैं. People know statistic, people know data science and machine learning algorithm, लेकिन उनको ये पता ही नहीं होता है कि statistic is correlated or causation of machine learning algorithm. How? This is the, you can see this is the Bangalore property price data set, and the location, size, local square feet, bath, how many bathrooms we have, price, BHK, price, square feet, and so on, right? So we are not going to detail of this, but we are going to focus on statistic part only. So we have very long data set. This is very huge data set. 13,200 records we have. Now we have df.describe, and this will give statistic value. Here you can see, say this 25 is percentile. Keep in mind every time this is being asked in the interview, like how would you illustrate the continuous data set statistic description. So this function only, this method gives so many parameters. Here you can see clearly count, mean, standard deviation, minimum, maximum. But what are these three values? These three are 25 percentile, 50 percentile, and 75 percentile respectively, right? So automatically it's giving, but we are more interesting in 99 point percentile and below 1 percentile rank, right? How to calculate it, right? So we are going to calculate minimum threshold, right, comma, maximum threshold, and this is going to assign my df dot, let me go for price per square feet, right? मैं अपनी प्रॉपर्टी को बहुत ज़्यादा कम रेट पे भी नहीं देखना चाहता हूँ और बहुत हायर रेट पे भी नहीं देखना चाहता हूँ. तो आई एम गोइंग टू प्रूव, क्योंकि प्रॉपर्टी में कुछ 1 करोड़, 2 करोड़, 3 करोड़ के भी होंगी. कुछ प्रॉपर्टी बहुत डैमेज हैं तो वो बहुत ही लो प्राइस की भी होंगी क्योंकि उनके थर्ड ओनर या कोई और रीजन की वजह से, राइट? आई एम नॉट इंटरेस्टिंग दैट काइंड ऑफ प्रॉपर्टी जो मेरे कस्टमर्स को पसंद ही ना आए और जिसको मैं अपनी वेबसाइट पे डालने के लिए मेरा स्पेस ऑक्यूपाई हो, राइट? So I'm interesting in real world scenario, right? So for this purpose, I'm going to set minimum maximum threshold, and this threshold is 0.01, so 0.01, and then 0.999. So this is 99.9 percentile, and then finally I'm going to print this value, right? So this is going to, for this column, we are going to check my quantile value. And this is the another method. You can go one by one, like as we have done in the previous section. First, calculate the minimum value, then calculate the maximum
Uh,
value, or you can go simultaneously. Yes, please. All right. So, okay, एक minute. 1 upon 100. This is 1 upon 0.1, right? Now we are going to run this code. You can see this is the minimum value and this is the highest value, right? If this property in the crore or the price per square feet, so I'm not interested in very high property, like might be for some million, billion candidates, right? In the Bangalore also, and for very low property, I'm not interested, right? So I'm going to set the actual scenario where I'm going to get this df dot price per square feet column. In this column, going to check what are these minimum threshold, right? So this minimum threshold is this one, right? How many values do we have? Let me take this shape. Will it give? Yes, 14 values, right? So 13, how many candidates we have? Records we have 3200. And if you will check the 0.001, so this is near about 13. Can you see this percentage automatically defined, this value is automatically defined, so that we can prune this percentage of data set. And manually, when we are counting the percentage, like 0.001 percentage of, like 0.1 percentage of my 13,200, that's giving 30 number only, right? तो उसके अकॉर्डिंग ये वैल्यू भी उतनी ही दे रहा है. Did you get your answer now, like we will prune more data set? So here we are losing only exactly 0.1 percentage data towards the left hand side. Get this point?
Yeah, yeah, got it.
Right, now we are checking for the maximum threshold at the upper. So maximum value then this, and you will, this will be again 14 for 100%, because that's also 1 per 14 value. Now we are losing 1% data set from either side, right? Now we are going to check, we are going to remove outliers from the actual one. For this we have, for this we have certain another data set, df is equal to df, and then inside this df I'll put the first condition would be for lower condition, and this would be the higher condition for the upper bound. So I'll copy the value here, so don't, so that I don't have to write again and again. So I'll paste it here, and I'll paste it here. So I need data set greater than less than maximum threshold, right? So that is less than sign here. I need the data set greater than minimum value. So I'll, like, which is greater than minimum value, right? So do I have correct inequalities here, right? If you won't put the correct inequality, you will get wrong data set. So keep in mind you are putting the correct uh, correct inequalities, right? Now we are going to calculate this one. Can you see? Still we are losing 2% data set. Still we have having very huge records, which was actually 13,200. After losing 1% data set from either side, still we have 13,172 without outlier, right? So that's my acceptance. Like if you go for the try part again, find the standard deviation 141, like what value for 6, and start 7 4.7, right? So there is a big difference in between every statistic comes, you find there, right? Do we have any query in
Yeah, yes.
the next word? outlier detection and well using IQR, right? And we will discuss what is interquartile range, and this here means how many technique do we have to remove outliers. We have three techniques actually. So first one is percentile, right? You can go for the direct method, or you can go for the percentile manual method, right? Second method we have G score. I'll discuss that method also. Third method we have called box plot, right? So we are going to focus on the third method here. I'll explain G square in upcoming session, but let me allow me to explore this box plot now. For this box plot, I'm going to import some, like we have already imported dataset. Let me check this whether it is stored in the head or not. No, we have not. So I'm going to explore one more time here. This is the height dataset, and now we have dataset in df variable, right? So when I go for df dot, okay, so this is already written here. So when I'm going to run this is, so this is already here, right? So when we are going to detect outlier using IQR, what we are exactly doing? First, we are calculating Q1, and what is the value of this Q1? Q1 is the method for finding the df dot heigsd for my height column dot quantile. Then we have 0.75, right? So let me find 0.25 first, right? For the same column, I'm going to calculate Q2. This is 75 percentile for the entire height column, right? I'm going to print Q1 and Q3 on the screen, right? Okay. Oh, Q2. So this is 5.35 and this is 6. But what exactly this Q1 and Q2, right? So let me go back for the Google, and if you go for the box plot, then you will find image, and in this image you will find copy so many things, right? In this image we have copy image and paste it here, right? In this image we have couple of things. First one, we have this Q1. This Q1 is nothing. This is 25 percentile data set. The second thing, we have 75 percentile, and we know what is the meaning of this 75 percentile, right? The data set below the value which is having 75 percentile below this one, right? And this middle value is called 50 percentile or median, you would say, right? This is not mean or not mod. Mod is what most frequently used data set. Mean is what average value of this. So neither it is nor mod value. Most frequent, mean means average of entire data set. Mod is most frequent data set available in my field, right? Let's say we have 2, 2, 3, 4, then 7, then 1, then 5, then 2, then 9. So the mean value of this 2 plus 2 will be 4, and then 7, 7, 14. The mean value of means the summing up of these value divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? That would be the average of this one. When you will talk about mod, so mod will be 2 because 2 is most frequent occurrence in my value, right? Now, what is the 25 percentile? In order to find 25 percentile, you will have to sort these values, right? So first we get 1, 2, 2, 2, then 3, and then 4, and so on. So either using formulae or by the given method, you can see here we are finding this value, right? So this value is for my this height column, not for this example, right? But you must understand the concept of this percentile and don't get confused with percentage every time, right? Now we have this middle value, and what is the minimum value and maximum one? Having any idea? All right, this is the very common question people are doing while studying this box plot, right? This is not the minimum and maximum value in my data set. So what I have done till now, as of now, I have sorted the data set in the increasing or decreasing order. I just find the minimum value. Users told me that the users check the minimum value and check the maximum, they write it down. I said it's a wrong value, it's wrong interpretation. Now go back to the code itself. I'll get IQ, I'll get lower underscore limit is equal to Q1, sorry, capstone Q1 and minus 1.5 times IQR. I'll also calculate upper limit for this value, Q upper limit. This is Q1 plus, here I'll have plus value, and this IQR. So what's IQR? IQR is interquartile range, which is simply nothing but minus 1. Obviously, you subtract higher value from lower one, then get the positive value. Automatically, it will give R print on this screen. Give the right 5.6.275 minus 5.3. Right. So we have this value. This value will pass to the formulae, and here we have both the upper limit and come back to the here we have lower limit and the upper limit, which is calculated by this and this, right? Now if you go for this diagram, right, copy this one. Now you can see clearly this diagram here this minimum value is calculated this formula 1 minus 1.5 times IQR. This is the property of box plot, that you will find minimum value on the basis of 25th percentile and 75th percentile. On the other hand, on the right hand side, we are going to calculate maximum value, which is Q3 minus or, okay, I think I calculate this value. Okay, so this is Q3, Q2 plus this one, right? I given the wrong formula. So this is Q3. Here they have Q3, but we are using Q2, right? It hardly matters, right? So we have this is as a minimum value and this is maximum value. Did you get this point? What is the minimum value and what is the calculate कर रहे हैं वो हम minimum maximum बोल रहे हैं, right? Otherwise तो कोई outlier होगा ही नहीं. Now अब ये जो values हैं 3.96 values हैं और 7.6 हैं, इनके below और upper जो भी values होंगी, they will be called as outliers on either sides. Did you get this point? As you can see in this diagram, up below this value 3.96 and above this value whatever the condition will fall, I'll call these values as an outliers. Now सिंपलर टर्म्स, इस हाइट में जिनकी भी हाइट लेस देन 3.962 से होगी और above 7.6625 होगी, I'll call these candidate as the beyond domain, right? Now, what are these outliers? So program Python, how Python calculates the outlier. So again, I'm going to calculate this one, and let me go for the first condition. This condition is df dot heigst. For this, how height should be lower limit, right? Or I'll get the another condition which is called df dot heigst greater than upper underscore limit, right? So if I run this code, all these four candidates are falling in the outlier conditions. This is the box plot definitions or basic fundamental of box plot. ये सारे outliers हैं. When you are trying to remove these outliers, you have something another condition. We are going to remove outliers. Let me create one more thing here. So for removing outliers, we need end operator here, and we need values greater than lower and limit and less than upper limit, and we are storing in another condition data frame. I'll call it this data frame as a no outlier data frame. And finally, going to print this on the screen as well. So you can see this Sakib, Toy, Virat, Dimitri, Selena, Yusuf, all are fulfilling average age of height, right? And if you are looking at 1.2.3, ये सच में एक बहुत ही awkward heights है. When you are looking at the 14.5, 43, और जब आप इनका पैटर्न देखो तो ये 4.9, 5.6 के अराउंड आ रहे हैं, और इन तीनों का आमिर, केन और लियू का आप हाइट देखो, they are actually outliers, right? So we have next question for the homework. So what's the question here? So for the exercise person point of view, this is the exercise. And what is the question here? Part C, part B. Here you will find the 1000 people data set is taken. Load the CSV in the pandas data frame and in the histogram for height and weight. From where you will get this data set? Let me open in the new tab. So here you will get the CSV file. You just download in the system itself, and then find the IQR detection and IQR detection for height outlier. First and foremost, remove height outliers. Fourth step, you are supposed to remove weight outliers, right?